Hello everyone, welcome to this video on mastering loops in Python. Loops are a fundamental part of Python programming, allowing you to repeat tasks and work efficiently with data. In this video, we'll explore advanced loop techniques like enumerate, zip, and list comprehensions, as well as best practices to write clean, efficient, and readable loops. Whether you're looking to optimize your code or tackle complex scenarios with ease, this guide will help you elevate your Python skills. So grab your notepad and let's dive into the world of loops. Introduction. Mastering loops in Python is a crucial step towards becoming an efficient programmer. Loops are not just tools for handling repetitive tasks, they also allow you to implement complex logic with minimal code. By understanding loops in depth, you can enhance the readability and efficiency of your programs while solving real world problems more effectively. This guide is designed to help you go beyond the basics and explore advanced loop techniques, best practices, and tips for optimizing your code. Whether it's managing large data sets, automating tasks, or building algorithms, mastering loops will empower you to tackle challenges with confidence and precision. 1. Advanced for loops. Use enumerate to get both index and value. When working with sequences like lists in Python, it's often useful to have access to both the index and the value of each item. The enumerate function makes this task straightforward and efficient. Instead of manually keeping track of an index variable, you can use enumerate to iterate through a sequence while simultaneously retrieving the index and the corresponding value. For example, consider a list of fruits such as apple, banana, and cherry. By using enumerate in a for loop, Python automatically provides both the index and the value for each iteration. This eliminates the need for additional code to track the index, making your loop cleaner and easier to understand. Using enumerate is especially helpful in scenarios where you need to process items based on their position in the sequence or when you want to include index information in your output. It is a powerful feature that improves code readability and reduces the risk of errors, particularly when working with large datasets or complex loops. Zip combines two sequences with zip. When working with multiple sequences in Python, such as lists, you often need to pair corresponding elements from each sequence to process them together. The zip function provides an elegant and efficient way to combine two or more sequences, creating pairs of elements that you can iterate through in a single loop. For example, imagine you have a list of names like Alice and Bob and a corresponding list of scores such as 85 and 90. By using zip in a for loop, Python pairs the first element of the first sequence with the first element of the second sequence, the second elements of both sequences, and so on. This allows you to process related data from multiple sequences side by side. During each iteration, the loop retrieves a pair of elements, one from each sequence, and assigns them to separate variables such as name and score. You can then use these variables to perform actions like printing a message that includes both the name and the score. The zip function simplifies code, making it more concise and readable, especially when dealing with related datasets. It is particularly useful in tasks such as data aggregation, report generation, and any scenario where corresponding elements from multiple sequences need to be handled together. 2. Nested loops. Nested loops are a powerful tool in Python, allowing you to process data organized in multi-dimensional structures such as matrices or nested lists. A nested loop is simply a loop inside another loop, where the inner loop executes entirely for each iteration of the outer loop. This approach is especially useful for scenarios where you need to handle data hierarchically or iteratively across multiple levels. Consider a two-dimensional list, commonly referred to as a matrix containing rows and columns such as 1, 2, 3, 4. To access each individual element in the matrix, You can use an outer loop to iterate through each row and an inner loop to iterate through each value within that row. For instance, the outer loop processes each row of the matrix while the inner loop focuses on the elements within the current row. During execution, the program accesses each value in a structured sequence, first iterating over all elements of the first row, then moving to the next row, and so on. Using nested loops, you can perform operations like summing all elements, finding specific values, or transforming the matrix into a different format. While nested loops are versatile, it's important to use them judiciously as their computational cost increases with the number of nested levels. For larger datasets or more complex processing, you might need to explore optimization techniques to maintain efficiency. Nonetheless, mastering nested loops equips you with the ability to handle a wide range of data processing tasks in Python. 3. List comprehensions. List comprehensions in Python are a powerful and elegant way to create lists by condensing the logic of a for loop into a single line. They are particularly useful for scenarios where you need to generate a new list by applying a specific operation to each element of an existing sequence, such as transforming, filtering, or mapping values. For example, suppose you want to create a list of squares for numbers ranging from 0 to 9. Using a traditional for loop, you would need to define an empty list, iterate through each number, calculate its square, and append the result to the list. However, with a list comprehension, this entire process can be written in one concise statement. The syntax involves placing the operation x2 followed by the loop for x in range 10 directly inside square brackets. The resulting list comprehension is not only shorter but also more readable, clearly showing the intention of the code at a glance. This makes it an excellent choice for tasks like mathematical transformations, filtering elements based on conditions, or even combining multiple sequences. List comprehensions are versatile and can include conditional expressions to filter or modify values dynamically. For instance, you could add an if condition to generate squares only for even numbers. By mastering this feature, you can write cleaner and more efficient Python code, reducing verbosity without sacrificing clarity. 4. Infinite loops. An infinite loop is a loop that continues to execute indefinitely because the condition controlling it never becomes false. In Python, infinite loops are commonly created using a while true statement. While they can be highly useful in scenarios like continuously running programs, server processes, or real time user interactions, they should always include a mechanism to break out of the loop to prevent your program from running endlessly. For example, consider a program that repeatedly prompts the user for input until a specific condition is met, such as typing exit to terminate. By using while true, the loop continues indefinitely, allowing the user to input commands repeatedly. Inside the loop, a conditional check ensures that if the user types exit, the break statement is executed, terminating the loop gracefully. While infinite loops are a powerful tool, they must be handled with caution. Forgetting to include a condition to exit the loop can cause your program to hang or consume system resources unnecessarily. It's essential to design your loop logic carefully, ensuring there is always a clear and reliable exit condition. Infinite loops are particularly effective in real time applications such as chatbots, game loops, or monitoring systems where continuous operation is necessary. However, always test your code thoroughly to avoid unintended infinite execution, which could lead to performance issues or an unresponsive program. By understanding how and when to use infinite loops, you can leverage them effectively while maintaining control over your program's behavior. Best practices for mastering loops. Mastering loops in Python involves not just understanding their mechanics but also learning how to use them effectively and efficiently. Following best practices ensures that your code remains clear, maintainable, and optimized for performance. Fundamental practice is using descriptive variable names within your loops. Instead of generic names like I or X, choose names that reflect the purpose of the variable, such as item, index, or name. This enhances readability and makes your code easier to understand. Another important principle is to avoid deeply nested loops whenever possible. Deep nesting can make your code complex and harder to debug. If you find yourself with multiple levels of nesting, consider refactoring your logic by splitting tasks into separate functions or using alternative approaches like dictionaries or matrix representations to simplify the structure. For simple loop based operations, leverage Python's powerful features like list comprehensions. These allow you to perform transformations, filtering, or mappings in a concise and elegant way. Not only does this reduce verbosity, but it also improves performance by utilizing Python's internal optimizations. When designing your loops, ensure that conditions are optimized to minimize unnecessary iterations. For example, if your loop checks for a condition that rarely changes, consider moving that logic outside the loop. Additionally, for tasks that involve mapping or filtering over sequences, explore built in functions like map and filter. These functions are faster and more expressive for specific use cases, often eliminating the need for manual loops. By adopting these practices, you can write efficient and readable code, making your programs easier to maintain and perform better in real world scenarios. Mastering these techniques is an essential step toward becoming a proficient Python programmer. Practice examples. Practicing advanced loop techniques is essential to deepen your understanding of Python loops and unlock their full potential. One such technique is combining enumerate with zip to process multiple sequences while keeping track of their indices. For instance, imagine you have a list of fruits and a corresponding list of their prices. Using zip, you can pair each fruit with its price, and with enumerate, you can retrieve the index of each pair. This approach is especially useful when you need to display or process data from multiple related lists while maintaining the order and clarity of your output. Another powerful technique is using list comprehensions with conditional expressions to generate filtered or transformed lists. For example, if you want to create a list of even numbers from 0 to 19, you can use a concise list comprehension. The if condition inside the comprehension ensures that only numbers divisible by 2 are included in the resulting list. Uh, this method is not only faster but also significantly reduces the amount of code compared to traditional loops, making it ideal for tasks involving simple transformations or filtering. By practicing these techniques, you can write Python code that is both efficient and elegant. These approaches are particularly valuable when working with data processing, reporting, or any scenario that involves iterating over and manipulating collections. Key takeaways. Mastering loops in Python involves understanding and effectively applying advanced techniques like combining enumerate, zip, and list comprehensions. These tools not only simplify your code but also make it more efficient and easier to read. For instance, using enumerate with zip allows you to iterate over multiple sequences simultaneously while maintaining an index, which is incredibly useful for tasks like displaying data or performing synchronized operations across lists. Simplifying nested loops is another critical skill. While nested loops are sometimes necessary for processing multidimensional data, excessive nesting can lead to code that is difficult to debug and maintain. Refactoring such loops into separate functions or using built-in Python features like dictionary comprehensions or matrix operations can significantly reduce complexity. Finally, practicing writing efficient and readable loops is essential for developing strong coding skills. This includes choosing descriptive variable names, minimizing redundant calculations within loops, and leveraging Python's built-in functions like map, filter, and reduce for specific operations. By consistently applying these best practices, you can write loops that are not only functional but also optimized for performance and clarity. These skills are foundational for tackling real world programming challenges effectively. That's all for this comprehensive guide on mastering loops in Python. We've covered advanced techniques, best practices, and practical examples to help you write efficient and elegant loops. Remember, the key to mastering loops is consistent practice and exploring how they can simplify your tasks. If you found this video helpful, don't forget to like, subscribe, and share it with others learning Python. Keep practicing, keep coding, and I'll see you in the next video.